There's a company called MakeBlock who has some cool kits, robotics kits. One of them is an XY plotter. They have a pen attachment. You can hook up a marker to it, use it to draw pictures. You can import SVG files and it will draw them for you. So here it is drawing a butterfly. They have some add-ons for it, one of them being a 500 milliwatt laser. The laser is really cool, and I thought it was going to be a lot of fun to play with. The problem is it's a little slow and a little underpowered, and you can see here when it's making a move from one point to another. Listen to it. It's going to stop here in a moment, move over, and so that was it transitioning rapidly from one point to another. Now this is all in the software that comes with the machine, the firmware for it. It's not very well done. So it is open source, so I decided to make some changes. I added my own laser, I made some changes to the firmware, and so this is the result. It goes significantly faster, the laser is more powerful, it moves back and forth between moves much quicker. The hardware is Arduino based, or I should say Atmel based. It's done using the Arduino software libraries. Bypassing those libraries, I was able to make it this fast. The problem is, it's still based on a single core chip that has some limitations. If you send code from your host PC to the laser, basically the host is sending a command, the laser processes the command, executes it, then says, okay, I'm ready for the next command, your PC sends the next one, and so on and so on. So while it is listening for the next command, it's not doing anything. And you can hear that when it runs. Listen to this, and you can hear it stutter constantly. That rapid fire sound you hear is the hardware pausing briefly while it's waiting for the next command to come over the serial line, parsing and processing the next command, and then it executes the move. So that's kind of inherent to the way that this hardware is built. The hardware has a really small buffer, so I decided to build a different piece of hardware based on the Parallax Propeller. Parallax Propeller is a multi-core chip, meaning it's got 8 hardware threads all running in parallel, and each one of those hardware threads is about the same level of horsepower, processing power, as one of the Atmel chips. So after doing some research, after setting up the board, skillet soldering it, I ended up with this. The code was pretty much a straight port. I just dropped it right onto the propeller. I made a couple of very minor changes to it, and if you listen to the sound of it, you don't hear that staccato stutter in between anymore, because the propeller is able to receive serial data and parse that data while another one of its cores is off executing the last move, and so it sounds much smoother.